Hello, world! Welcome to Code or Not to Code. I'm Nearly Eva and I'm super happy to be here today. And as always, I'm here with Stefan. How are you doing?
Hello, I'm doing great. Other than I almost missed the startup signal.
No worries at all. We're back with a super exciting episode for you. Thanks again for joining in. Um, yeah, if you're new to the show, Stefan and I have been friends for a while and we love to code. And we're currently building a .NET tool live on the stream with you, our wonderful viewers. So yeah, if at any point in the stream you have any questions, comments, or you just want to help us out, please do so in the chat. We always love connecting with you guys. Again, if you haven't seen the tool yet, we've already gotten a couple of features that work quite well that have to do with global using. So we have like the user, we've got the counter and oh my God, let me start it again. We've got the counter and the globalizer. The counter counts your local usings in your project or solution, and the globalizer globalizes all of them or some of them or whatever you want to globalize. We have a bunch of episodes on those topics, so definitely go on, catch up on them if you're interested. But last time, if for those of you who were here, we had a super exciting episode where we were looking at Interceptors, which is a super experimental new compiler feature of C# 12. And we're going to continue with that a little bit today. We have a bunch of to-dos. We have a bunch of things that we need to still adapt and want to try out with you today. And I'm super excited for that. I had a great time last time, so I'm really excited that we get to continue on that this time. How do you feel about it? You're already like grinning. You have a big grin on your face, so I'm sure you're
Yes,
excited as well.
yes. Well, we had amazing progress last time, and now we have the core functionality working. So now we have to make it a complete feature, and then I guess it's quite releasable.
Woohoo! That's so. We were really good last time because we also kept within our time frame more or less, which was I think a first for us. Not a first. We started off. I remember when we first started streaming, we were really sort of like everybody like was looking at the clock and we were super on time with everything. And now we just go on until it's done. And if it's 4 hours, it's 4 hours. I would love to see people because obviously, like for us, it's quite late when it goes on for 4 hours, and I always get really sleepy. But like if you're watching it at like 11 o'clock during the day or at some point, it must seem really silly because like my concentration like goes like this with every hour. But yeah, never mind. We're at the beginning of the episode. We're full of energy. We're full of enthusiasm and ambition. I'm ambitious today.
Oh yes.
But before we get into the code, a couple of public service announcement. First of all, if you would like to stay in touch with us, if you're interested in our content, in what's coming up, in our progress, in our tool, in anything we do, please give us a follow on Mastodon. We love to hear your questions, comments, and generally just connect with you guys. And second of all, before we start with the coding, with the interesting part, we always have a little news section. So let's have a look at what's new in the world of .NET. What have we got today?
So what happened last week as well is another episode of the OSS Power Ups. That is a series hosted by JetBrains and in particular hosted by Matthias Koch, who has also been at our guest. Yes. And they were powering up mass transit, which is a framework for not multi-platform, I'm missing the word, distributed applications and platforms, and they facilitate building this in the world of .NET. And there is a recording of this wonderful session.
Woohoo. Matthias is so busy. I always feel like, does he also have 24 hours during his day, or does he have like double the amount? Because it feels like he gets so much more than me.
Maybe he found the key to time.
Yeah, he did. Okay, what's the second link?
What also has been announced is the great .NET 8 hack, so .NET 8 hackathon, a virtual hackathon where you can build cloud-native apps or AI apps or .NET MAUI apps. And there is also a prize pool for the winners in the categories or the overall winner.
Yeah, and everybody gets a digital badge, so that's always nice. I had my first hackathon a couple of weeks ago, and it was actually really fun. It was more fun than I thought. I was very nervous. I mean, we didn't win, but it was super fun.
Because it was sabotaged, if I remember correctly.
It was totally. I will defend that point. We were sabotaged with pizza. Happens. How many hackathons have you been to, Stefan?
Not so many, actually. I think 3, I believe, so far. Yeah.
Okay. Thrice the amount of my hackathons, right? still something. And I can already sort of see the next link.
.NET Conf. Because .NET Conf is upon us, so it's in less than a week. So we just have to sleep 5 or 6 times, which also marks then the release of the next version of Visual Studio, and of course .NET 8, which is currently in release candidate, and then it's fall 8.0.1 SDK, and I am particularly excited about this because I also have a session there, and who would have thought it is about interceptors? So I try to make this like a 30-minute condensed version of what we streamed today and last time.
That's so cool. I think it's really cool that you're part of it.
Yay! And there is like so many more sessions. It's 3 days of full content on everything.NET and what's new in .NET and C# and ASP.NET and MAUI and Entity Framework, and I can't name all the things.
Yeah, there's always like so many cool speakers and so many talks and so much. Yeah, it sounds amazing. Yeah. I think it's so cool that you're going in person as well.
Yes.
All right.
And I guess before we get started, Basi92 is here.
Hello. Thanks so much for joining.
And also, you salty devil.
Yay! Hello. Welcome back. Well, no, you were back. You were there last session as well, I remember, but I think the one before you missed. But yeah, welcome back to everybody who's back, and welcome to everybody who's here for the first time. Please stay.
I think you need to speak more in the microphone.
Oh, sorry.
When you move, I think then it gets a little bit more silent.
Okay, sorry. I keep changing my setup, and then I destroy everything. Hey, it's my passion, moving stuff around. Okay, let's have a look at what we did last time.
So what we did last time, it's on GitHub. I'm posting in the repository. So this is currently a branch, not merged yet. This is the session that we did with Jason Bock last time, where he helped us understand interceptors and also build the core functionality about finding these interceptors. So I guess let's rewind and see what are these interceptors. So strictly speaking, interceptors are not a C#12 feature, but more of a C# compiler feature that has been released around the C#12 time frame. So it's a compiler feature, but it only works for C# projects. But it's not directly what do I have here? It's not directly a C# feature like params or generics or something. It's a compiler feature. And what the compiler does, it allows rerouting method invocations to a different method. We have here, I guess I need to zoom in more. So this is the standard .NET API template. If we have let's see which version of the .NET SDK we have, .NET -- version. We are running on the latest release candidate. In a week, this will be gone and it will be just .NET 8. And if we see .NET new list, there is a Web API AOT template. So it's a ASP.NET Core Web API, but with AOT. That's ahead of time compilation. The difference is to regular .NET apps is in regular apps we also have a JIT compiler. So let's see if I can do this now. Control W. No. Control W. There we go. So we have our C# code that gets compiled into IL code, that's intermediate language code, which is then deployed on a machine. For example, this is put on a, let's say, Windows 64 machine. And then the .NET runtime has a JIT compiler that is now just in time compiling this IL code into Windows 64 compatible instructions and to real machine code. So that I shouldn't have done that. Oops. So the IL code is not really executable, but the good thing is it's portable. So you can move it to any platform, and then the JIT compiler will be compiling it directly into the machine for the machine needed. The thing is that JIT compilation, we actually have at runtime a compilation step. So this costs some time. So we pay a bit of a startup time, a price at startup, which is not the best for very short-lived applications like Lambda, ASW Lambda functions, or Azure, what are they called? Azure functions. Those services as a function, which may live for a short period of time, but you do pay for this time. So you could, well, it's not a lot, but it adds up. You could save a bit of startup time if we could get rid of the JIT compilation. Also, at some platforms, I think at iOS, there is no, it's not allowed to emit new code at runtime. For example, with the power of the JIT compiler, you could at runtime emit new IL code at runtime, compile it with the JIT compiler, and then execute it. This is, for example, done with regex. Is it regex or regex? Regular expressions. There is an optimization where in .NET you can then, at the first invocation of a regular expression match, you create new IL code, just in time compile that, and then have for so the first invocation is slow, but then every consecutive invocation of a match with this regular expression is then faster. But if we don't have any JIT compiler, we can't do this, emit new optimized IL code. So we can't do this. And what we have to do is, since we have no JIT anymore, we need to shift these JIT just-in-time compilations to our C# compiler, to ahead of time already. And this is where source generators now, or incremental source generators, can come in. So what we would have generated at compile time, highly optimized code for the current workload that we have, we could do via a source code generator. I write gen here. And this generator, just as the runtime code we had, would inspect our runtime and create new IL code. Now the generator could inspect our C# code and create new C# code. And then everything could be compiled first to IL, but then it doesn't stay there, but then from this IL goes then to an AOT compilation. So that's ahead of time compiled. And this is now machine dependent. So this would be, for example, directly for Win64 or Linux 64 or iOS, macOS 64. If this is different targets, I'm not certain. So this is now only running on this machine. But the advantage is we don't have any just-in-time compilation. There is no just-in-time compiler anymore. So we save the startup cost. And we already, those features which need the just-in-time compiler, we have replaced with source generators. And one of these use cases is minimal APIs of the ASP.NET Core Web API. So we have here those map gets, and those map gets, I think behind the scenes, would also use dynamic code. or would also use reflection. The thing is, reflection code is also inspecting our code at runtime. And if we have code like that, then our application is not very trimmable, because what we also have is trimming. So if we have, let's say we have a bunch of C# code, just right, this could be methods or something. But what if we are not using all of the code? We are only using a part of the code. We could eliminate the code that is not used and then make the final application reduce it in size potentially significantly if we get rid of stuff that we don't need. But if we use reflection, since reflection is evaluated at runtime, we don't know at compile time really which code is now referenced and which not. So replacing reflection calls also with source-generated code, and again, shifting this runtime complexity to compile time complexity, now also not only makes our apps AOT friendly, but also trimmer friendly. So we get small applications that don't need just-in-time compilations anymore. Well, this is not certain. This doesn't mean that every app out there should use this. But for example, cloud functions as a service apps are very prevalent to use this, depending on your workflow. And now with Interceptors, we could now make use of this feature and enable AOT compiling, for example, for an ASP.NET Core Web API, the minimal Web API. The not minimal API that has controllers and such. So the minimal APIs don't have controllers. You basically just declaratively state what you want to map, for example, the root path or just an ID route. And I think what happens behind the scenes, there is some dynamic code and some unreferenced code. So this is reflection and reflection emit. So then emitting new IL. I think, I'm not entirely sure, which means now this app is not really trim friendly and not really AOT friendly. Now, I could rewrite the code to be AOT and trim friendly, but that's very tedious. So what if a source generator could generate the code that is needed in order to make it AOT and trim friendly, but I don't want to really notice it. So the source generator now could emit an interceptor that intercepts these invocations and does the AOT friendly thing behind the scenes without us needing to change the code actually. So what we would have here is, if we have a look at it, what would actually be invoked is the method mapGet on the mapGet. This is an extension method on endpoint root builder, and it's returning a router handler builder. And instead of this method being invoked, now what we have, because in our CS project we enabled publish AOT, we now have a source generator. We see the source generator here. That's the delegate request delegate generator. And this is not generating new code. We see this is generated by a tool. It cannot be edited. In the name, if we have the name, if I see that, the name it says .g.cs, where the G stands for generated. We also have the generated comment on top. So this generated code, it emits some attribute. And with the use of this attribute, we can decorate new methods. And now this method is called instead. So what we have is we give in the path, the C# file, where the intercepted call is, and at which line number and column number. And it says program CS at line 21, character 10. If we go into our file, into our program CS, line 21 and character 10 is here. And this basically now denotes that this mapGet invocation is now intercepted. And we no longer call into the method that we would call without the interceptor, but we actually call into this interceptor. So we can do a breakpoint here, run this application. And we see that this breakpoint gets hit. And we no longer call the original method. If this attribute wasn't there, this method would not be called, but the method that is originally referenced here. And now here we are emitting source-generated code that is very special use case for our application and moving all the potentially needed runtime complexity to compile time complexity, and makes the app trimmable, AOT friendly, and amazing.
Cool.
The thing is that interceptors currently are an experimental feature, so they are not recommended to use in production, and therefore tooling is not that super advanced yet. Of course, because it's an experimental feature, it could either stay the same for .NET 9 or .NET 10 or whenever. It could change significantly, or it could be removed without replacement. Everything is possible. So there is, of course, no investment in tooling. And just looking at the source code, it's hard to see which methods are intercepted. We don't see that this is actually intercepted.
Yeah.
And if we were to change publish AOT, say, no, I don't want an AOT application, I just want a regular JIT compiled application, nothing changes in my source code. Only the source generator that we had here is now gone. So there is no interceptor invoked, and now we actually call into the original method because the interceptor, this method is now gone. And tooling currently does not really make this. Of course not, because it's an experimental feature, very obvious. So what is intercepted and what not? We thought this is now a gap that we could fill. We could understand which are the interceptors and list them for you. And so you can see, is there actually interceptions going on? And if so, where?
I love it. I love that it's such an experimental feature, and we're sort of working on it, because every time we say last time as well, there was so many warnings, I think, on the documentation. It's like, oh, don't use this, and I always wanted to say in the streams, don't do this at home. Don't touch it in your production for your applications if you're running them in production. But no, it's.
I think there is the warning. Yes. Big warning.
Massive warning. Scary stuff. I love it. Cool.
And what we built, yes. So what we built, if I find it. There it is. What we built last time with JSON is our first interceptor. So we built a little test where we have, it's very similar to what we saw in the ASP.NET Core example. We have some call site where we have, console.writeLine. We invoke some interceptor.foo, my class bar, my class baz. Then we actually have those types, intercepted foo, my class bar and baz. And we also, well, it's not generated, but we write it ourselves. But here's also the interceptor. We see here's the very same attribute. This is basically copy-paste from the ASP.NET Core example. And also some interceptors. And we see that we intercept at callsite.cs, line number 10, column 21, which is now, if we see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, line number 10, and character 21 would be here. So it's the foo method that we intercept, but we also intercept those two. And now we would like to make them, unveil them. And if we want the test, which is currently not, well, it is a test, but it's not testing anything. It's just printing to the output. We see that we have here the interceptor information. Those are the 3 methods that we found that are attributed with that attribute, and the call sites that they intercept. And what now would be cool, because currently in our interceptor that we built, where we have built a syntax walker that checks all method declarations, because currently only methods can be interceptor, and also only methods can be intercepted. We find all methods, we look for their attributes and see if any of these attributes is this intercept location attribute to state, okay, this is an interceptor. Now we extract the three parts, the file path, the line, and the character, and just put this into some list. And then in the second pass, which is up here, we go through all documents. We see, does this document now contain interceptors, what we got from the file path, and then find with the line number and the character number, we go find that node and then print it, and just print it. And what we'd like to do as a first step, because currently this result is only just a string that we print to the console, we actually would like to have a more structured string that we can then also assert our tests against. We would like to put this into a structure that we asked Jason last time, what would he find useful. So it would be cool to list first the file that contains intercepted method invocations. Then beneath this file, we have those two, or three, in our case it's three, methods that are intercepted and at which line number and character number they are. And then for each of the intercepted method, also list its interceptor. So this will be the generated document that now has the interceptor that now is actually invoked. And we would like to print these. So we need kind of a data structure that holds a file, class, a string denoting the class that contains interceptors, or not the class, but the file that contains interceptors, or the document, and then the interceptors that it has, which are, again, I guess, maybe a method or some identifier, line number, character number, and then the interceptor, which consists of, I guess, just this, maybe two strings, the document that the generator is in, and the signature of the method. I guess this could be then helpful.
The signature? Sorry, what is?
Well, it's not really the signature, but the fully qualified name of the method. So the namespace signature was a wrong name. So the namespace, the type name, the name of the method, and also its arguments that it contains.
Okay. Got it.
And I guess now we would like to create this data structure that we can then fill. So Interceptor is currently returning just this result string. I guess let's get rid of that. And let's start building a data structure that contains what we need. Maybe I should copy this over there so we see it.
Okay.
So how could we picture this? I'm now giving it like a second example. So we have, second one could be now my class 2 that also contains interceptors. So what we could, excuse me?
No, go on. Go on. Sorry.
So what we could have is either we could have a flat list, or we could build a dictionary that has the documents that contains interceptors as a string. Both would be possible.
Dictionary sounds good. I heard the term concurrent dictionary for the first time a couple of weeks ago, but that has to do with multi-threading, right? Or like it's thread safe in some way. Do we need that here? Probably not, right?
We currently not, or we don't have. No, we don't need it. Well, we don't. We could make our code concurrent.
Yeah.
But currently, well, our code is async, but we are not doing really concurrent work. So that means we are async. We don't block any thread while we are waiting for results, but we are not really doing anything concurrently. So we are saving resources, but we're not utilizing the resources to its best. But this could be a future optimizations to I guess for our project we currently tested, they're very small. We won't notice any difference.
Yeah.
If this would be applied to huge projects, and then we could potentially see that it takes some time. This could be then a performance improvements to use concurrency, and then we need concurrency enabled collections like concurrent dictionary. Yes, but long story short, for now, no. Later, yes.
And what did you say? Like did you say flat list, or what did you say? What was the word?
Yeah, we could also just have a list of these items that have like, now this data structure is some type, but then we couldn't like search. Well, I guess it doesn't really matter how we wanna.
Any preferences from the audience? Doom. Speak now or forever hold your peace. Do you have any preference, Stefan?
I get not really. And if I would have, I would change it immediately afterwards. I'm not really.
All right, let's try dictionary because I'm interested in it.
Would like to build that?
Yeah, I'm already googling. Oh wow! I did it again every single time. I literally just clicked on the stream and typed there. I really don't learn. I learn a little bit, but very, very slowly. All right. Okay.
So let's perhaps start creating a new dictionary as a private field that we then later on fill.
So you had the. Sorry, I'm very confused. Because the to-do is here. You can see me, right? You can see. Yes, I need 3 screens. I only have 2. That's ridiculous. So should I put it then on top of the to-do, below the to-do, or should I just put it at the end?
How you like. The to-do eventually will disappear, so it doesn't matter.
And you said a private field, right?
Mm-hmm.
That's what we said. Private. What is it?
Dictionary.
Oh, okay. Dictionary. And then we probably need to define a type, right?
Mm-hmm. So the key for now would be a file location or a file path. So that's a string.
A string.
And the value now, we need some data structure. Either some data structure, or again, we could have a nested dictionary.
Yes. Yes, like this.
Yeah.
And then we put another.
And now this nested dictionary. Okay, so here we could. Well, you know what? We could start simple. We could just. We could put this later on into nicer data structures, but we could start simple. Then also have, now this could again have a string as a key. Yeah. No, not a dictionary.
I know.
But this dictionary now could have a string as a key, which would now be the intercepted. And then as a value, just another string that is then the interceptor.
Okay. String.
We could, I guess, later on, perhaps we even move this entire thing into a separate data structure to make this more testable. But for now, it could. And also, as long as we keep it private, as long as we keep it an implementation detail, it doesn't really matter, because we can nobody wouldn't. Well, yes. But no consumer shouldn't know. Consumer shouldn't care about the private implementation detail. That means we can change it to something else afterwards. And if we don't change the public surface area, everything would be still compiling. We can just exchange this easily. We just need to touch this one type as long we define our public and internal methods nicely. And the privates, they don't. Well, they do matter, yes, but they are easily changeable.
Okay. What do we call it? Do we need a name?
Perhaps we call it dictionaryception. Or maybe interceptors. I don't know. No, guess what the devil is suggesting. Is asking if this is dictionaryception, because we have dictionaries of dictionaries.
Ah, nice. I get it now. Interceptors is what you said.
Interceptors, yeah.
Right. And then we probably need this new keyword, right?
Mm-hmm. initialize it, yeah.
And then we don't need to write dictionary and stuff again, which is what I always do. But because we already have it on the left-hand side, can I just do it like this?
Okay. Yes, since is this C#9, C#10? I think C#10. Not sure though. So if the compiler knows from somewhere which type it is, in this case knows because we already declare it here, it can infer it, and this is, I think it's, what is it called, a target type new expression. So this new knows because of that what it should be newing, and yeah. Since this is a private field, we wanna make this start with a lowercase character.
Oh, sorry.
And also, I think the guideline we have is that for private fields we also use an underscore.
Yes. Sorry. Oh,
nothing to apologize. And now we could let's enable adding to this dictionary. But let's do this so let's have a method. Maybe add interceptor. Or just add, because this type is called interceptor list, so maybe just add suffices. But let's also make this internal for now. But because we will call this from our core logic, but our infrastructure, which then uses this type to display the results, shouldn't be able to add it. So from the perspective of the consumer, it should be immutable. But we can use it as a bit of an builder type and still internally add to this dictionary.
Okay.
Since it's a method, we always need a return type.
Oh.
And if we don't want to return anything,
no. What are we? Wait. What are we?
Then it's
a dictionary, right?
No. We don't want to expose this dictionary. So in our case, we just make it void. Yeah.
Okay, and then we need this. Yes.
And I guess the parameters would be. So we have a file path as a first parameter.
Yes, which is do you need,
Oh, not a parameter. Doch, parameter is the correct word. So we want to, the caller should supply this.
Got it. I don't need to write string, do I?
Yes. In the arguments you have to, the parameters you have to explicitly declare. Well, you could write object, but nah.
No. I want to write dictionary, but I have to write string. I'm in love with dictionary. That's my thing for today. We want a string, and you already said it to me, and it's file path.
File path.
Yes.
So that contains the interceptor. No, the intercepted. Then we have the, well, perhaps let's call it.
Do we have a dictionary? Do we have a dictionary? No, we don't.
No. No, because we want to keep this dictionary as an implementation detail. We don't want to leak it too heavily.
This dictionary.
Yes, but we don't want to leak that. So what we are now adding is we want to add a string that contains the intercepted, and one string that contains the interceptor.
Amazing. No dictionaries in this method.
And now let's add to this dictionary.
Woohoo! All right. And that's interceptors. Yes, I have a question. What's the difference between add and append?
There is no append to a.
There is? Woohoo!
Yeah, but okay. The append, however, that's a link method.
Oh.
That is if you want to append, if you have two sequences of enumerables and you want to append one to the other. But then we get a new sequence. So with append, we can't really add to this dictionary. So we want to use, so we don't want to use extension methods here.
Okay.
We want to use the add from the dictionary. So the add is actually an instance method from the dictionary to add a new element. And the first element is the key, the string, the file path. And then, the second now would be a new dictionary.
Yes, it would, wouldn't it? Oh, that's amazing. Dictionary of type, string, and then wait, let me do it. I can do it. No, wait. Do I need these as well as the curly ones?
There is different methods now how you can initialize it, but yes. Yeah.
Perfect. And then we need the intercepted and interceptor. Easy peasy lemon squeezy. No, I did something wrong.
Yeah, unfortunately, because it's a dictionary, and the dictionary is a collection. What a dictionary is it's a collection of. Where do we see that? It's a collection of key value pairs. Or it could be depicted as a collection as key value pairs. Now we need a pair here. So unfortunately, we're almost there. We just need. Okay. So those are the curly braces for the collection initializer, but we also need curly braces for each key value pair, and then we're good to go.
Okay. Fabulous. Easy. Easy.
And this code will cause problems later, but we'll figure this out.
Come on, I was so proud.
This will. No, it's actually that's a good start. But there will be a problem.
All in one line. I mean, this is very unlike me. I think I pat myself on the shoulder. Usually, I use all the space, and then Stefan comes in and does it in one line, and then I feel like an idiot.
This is I like the use of the collection initializer. It's perfect.
Perfect. Okie dokes. So we can.
And I guess we also. Now let's also add a method so we need to be able to extract it. So let's add a method how we can get these. Perhaps what we could have is an enumerator that lets us enumerate these results.
Okay.
Would this be helpful? Maybe yes.
Let's do it. But this needs to be public now, or
yes. So we want to now make something that we can access from the test.
And return type.
What do we return? If we want to make it enumerable, we could return an IEnumerable.
Oh yes. How?
Of. Okay. So this will be generic of. What should this return? It could return an. Well, it could create a new type. Perhaps you call it interceptor.
Yes.
And the intercept. Now let's create the rest of the method. We can call it, let's say, enumerate.
Enumerate. Yes. Okay. Ooh.
What does it suggest? Let's see. Well, it's a fair start.
I love that you can kind of read it. I love that you can read it on my face, and I'm sort of seeing a suggestion and trying to figure out whether it's actually useful. Anyway, yes,
it's a fair start.
It's a fair start.
So let's first create the interceptor type. I think you should be able to just Control dot or Alt enter it and then create a new type. And maybe let's create it in the same document for now. Do you have this with factoring? Yes. Okay. And this interceptor now, let's have the compiler do all the magic. Let's turn this into a record class. So you can just write between public and class, you just write record. Yeah.
I thought you can also just write record instead of class.
You could also have just record, and now it's the same as a record class. However, there is also a record struct. And so a record struct you have to explicitly declare to make it a struct. The record class is implicit. But since I find it weird I personally find it weird if you have for the classes you omit the keyword, and for the structs you explicitly state the keyword. So this is why I personally prefer to always explicitly declare the class keywords to make it obvious and explicit. But it is, as you said, purely optional. And now with that syntax, we can just add a parameter list after the identifier of this record class and just add the information that we need, which is hold on. This is a bit, no, maybe I haven't thought this through because we need to, so this is one block. We have many of these and this. How do we best depict this? Because we want to print then this once and per multiple times. Well, we
just to,
you know what? Let's for now just make it simple. We can optimize later, and just do it like this for simplicity, and we optimize later to group them more efficiently. So let's potentially have duplicates here for now, and let's keep it fine. So let's have this be 3 values. We have the file path, the intercepted, and the interceptor, all as a string.
As an input parameter.
What?
Yeah. You said all as a string, right? Sometimes I hear you, and I know I hear you, but I'm thinking about something, and then my brain has to catch up with what it thinks you said. So
if you have a better idea, well, I'm now keeping it very string based. I guess.
Well, you know what I was thinking about? I was thinking about dictionaries. But I don't think that would work because then I was thinking of because then you could print the key once and then the values, which would potentially be more. Right?
We could also, we could also return a dictionary, I guess. Yeah.
But I like strings are simple, and I think
Well, we will definitely change the structure, but it will be our starting point.
Yeah. And then we had a string which was
intercepted.
And
the interceptor.
Okay, that sounds familiar. I think I've written that a million times already. Interceptor. Woo.
And now here, yeah.
No, I'm just gonna. How do you say when you sort of give yourself boost your own confidence, blow your own horn? I don't know. Something like that in English. I was just gonna say that I typed faster than I usually do. Anyway. Nobody notices it. Everybody who's new watching is like, she's so slow. What is she talking about? Everybody who was here for our first episode must be like, whoa, I can't follow you anymore. She's so fast. Anyway, let's continue. Sorry. Okay, what do we do? We've got public record intercept. Okay, done. And then.
So now we want to. So what we want to do now is basically transform this dictionary into this data structure. So let's for each the dictionary.
Wait, where in the enumerate?
Instead of, so let's remove that. Yeah.
Yeah. Let's for each it. That's not it. Isn't there a tap thing?
Should be.
Oh, no, I did it. Okay.
And then for each, so this now will be a list. So this is now we have here, but we have a dictionary of dictionaries. So now we need an inner for each to also iterate through these.
No, that's not it.
Yes, it is.
Oh, it is. Interceptor.
Well, name it. Well, yeah, because we already had interceptor, so this refactoring added a 2 to make it compilable.
Okay. Interceptor 2 it is.
But here we can't for each because this is the result here is a key value pair. But from this key value pair, we wanna use the value because the value of this key value pair is a dictionary. Yes.
Got it.
And now in here, since we want to create an enumerable, we can now yield return. Have you used that before?
No, but it already prompted me twice. So it feels familiar.
We'll return a new interceptor and just fill in the data that we have.
We return new. No. Do I have to write new?
I think this could be inferred. I think the compiler should know, hey, we want to return interceptor here, so this could be target typed potentially. But so yeah, we do need the new, definitely.
Okay.
Question is, do we need to specify the type, or does just a new suffice?
Let's do it, and then let's have the compiler remove it when I'm being silly again. Okay, and then
so the file path will be, let's go a little bit up. So the file path will be from up here. So this will be, do you know where we have the file path now in those variables that we have? Variables.
In the interceptor in this one, right?
Mm-hmm.
No? Yes.
Yeah.
Okay. Interceptor.
But what? Because that's interceptor is a key value pair?
Yes. Dot. Is that the key?
That is the key indeed, yes.
It is the key.
Yes, because if this is our key value pair here, key and dictionary is the value.
Yes.
And now for this dictionary, we have another key value pair where both are string.
Okay.
Now for the intercept head, where do we have the intercept head?
Value dot no, interceptor 2 dot key.
Yes.
Interceptor 2. This is because it's interceptor 2 dot key, and then we have interceptor 2. Take everything back. I'm super slow again. Value.
Right. Cool.
Easy peasy.
Now let's do some assertions. Okay, cool. Yes. How do we best assert this? I have not thought this through at all. So we have here okay, first let's get rid of this, because we injected here the output helper so that we can basically print a string. We won't be needing that again anymore. Well, we need it again, but not anymore. Yes. So that enumerate, but how can we now best? I think there is an assert where we can enumerate, where we can check enumerables. Is this like the collection assertion? Maybe it's the collection assertion, because the collection assertion allows us to give an input collection and then define the parameters of actions, which inspects each element, and then for each element we have another assert.
Wow.
Can you imagine what this looks like?
No.
So we now pass in. Well, it also took me a while too. I haven't used it in some time. So we have the input collection. So this would be the actual.
Yeah.
And the element inspector for the actuals. And now this is a params of action.
Okay.
And what we learned some time ago, an action. So there's an action of T, where our T is now our interceptor type. So we definitely need to call enumerate on that.
Okay.
So we enumerate, we receive now this interceptor type. Since we made this interceptor type, we made it a record. This now also is comparable and everything, so we can utilize this already.
Okay.
And now we have a params of interceptors, an params action of interceptors. So we can add now multiple actions, and we can also, since an action is basically a function pointer, we could point to an anonymous method, for example, a lambda, where we now could have our item. So this will be the item at position 1, and item at position 1 should be the first interceptor, which is in the document call site. Basically now asserting, we say assert dot equal. We expect that this item, the actual is the second, but the expected is now this new interceptor, where the file path is the call site, where the intercept head is basically this information. We have, I guess let's take a look at the test. No, where's the test? The code. There we go. Okay. No, where do we have this? There it is. Oh. So we have my class. So the type of the, I will copy this over and then fill it with the correct data. And the second one will be, oh, come on. I just looked at it. Where is it? There it is. And the second one will be then this one. Okay, so first we have, wow. Okay. So the intercepted will be basically this call, intercepted.foo, at position 10, no, at line 10, character 21. And then the interceptor is in the document interceptor.g.cs, interceptor.g.cs, and it will be in the my-generated namespace, and it will be this interceptor 0 method. And it has no parameters. And we compare this to the item. And since this is an, yeah?
But we're enumerating through. So how can we? Oh, because you said, no, I don't quite get it yet. Because how can we hard code what we want to assert if we are going through a dictionary and asserting different things?
Well, we are no, well, yeah, we are originally going through a dictionary, but we are selecting basically this. We could also represent this by a select statement.
Oh, expert in training.
So we are creating a projection. We project this to new elements, to interceptor, and this will be now a public type that we want to expose. We don't want to expose this dictionary. It's just our memory locator that we can change at will. But this will be our public API, a public interface. And now in this test, what I currently assert is that this enumerate contains, this enumeration, this collection contains one item because we have one action here. Okay. And this item, we can basically do anything with this item. But this item is asserting this item. And if we want to assert the other items, we can just add this 3 more times. Now we are asserting that there are 3 items, and the other items now should be the my class.bar and so on, just copying stuff over at line 11 and 17. I guess later on we will change this from a string to a proper data structure that has the file path and line number and so on. But for now, the string will suffice to as a starting point. And we also want to, and the interceptor will be this one, and it will take a string. And I guess this should be it. And if I were to remove one item here, now the assertion would, if we actually return 3 elements, but we expect 2 because we have an action of 2, now this would fail the assertion. Likewise, if we would expect 4, it would say, hey, you listed 4 elements, I only have 3, no can do. And then for each element, whatever we assert here must also return successful or must not throw an exception to succeed.
Got it. Cool.
And I guess now we just need to implement this method, because if we run it now, it will, we have a failing test. Oh, it will even not compile because, oh yes, interceptor list. Let's just return that here. Well, we now just return an empty interceptor list for now, because we changed this type's constructor.
Oh yeah, okay, got it.
And this test should dramatically fail. Oops, wrong one. There it is. No, there it is not. There it is.
Oh.
And it does because, yeah, expected item count 3 because of our free actions, but actual item count 0. So now let's actually go to the implementation and let's fill this interceptor here.
Yes.
And perhaps I will move this type. Let's call this result. Let's remove this. Well, let's actually exchange this result to this new interceptors list. So we now our result type. Let's get rid of this for now. And let's now here, because what we do have is this add interceptor method. And this add interceptor method now requires these 3 arguments. Okay. And let's fill these correctly.
Yeah.
So we need the file path, the intercepted, some intercepted string and some interceptor string. Perhaps let's write them like such. And then we just fill them. Just as empty strings for now. I will copy over an assertion from our tests to make this, to basically have a template of the format that we want to fulfill. So if I would be hard coding it, this would be the file path, this would be the intercepted, and this will be the interceptor. Yeah, we already have that name.
Just intercepted 2 again.
Let's go with 2 for now, yeah. Okay, so where do we get our file path from? I guess we already have it, because in this interceptor info, because we extract from our syntax walker, we extract this interceptor info that contains file path line number character already. So we can feed that in from here. We'd like to take over.
Yeah. Yes. What is it called again? The
interceptor info in this scope, it's our interceptor variable. Damn it.
Oh, is it? Where is it? I can't see it. Where's the
interceptor? I'll scroll up. So at my position.
Okay. Sorry. I think my ID was a bit slow and I couldn't see all the colors, and then I find it very difficult to find anything. Okay. Interceptor dot file path. Yay. Okay. Intercepted.
So this will be now, I guess this will be now an interpolated string. So first we want the intercepted, this will be contained in this information from this node.
Okay, interpolated string. So let's start with the method, right? So that would be no. Wait. How does this work again? Do we need the curly thingies?
Yes, but we do need one like so.
Yeah, got it. Okay, node dot. Oh my god.
I wouldn't know either. I wouldn't know either. Let's go with 2 string for now and see what's happening. I really don't know.
Oh, okay. 2 string.
Let's 2 string it and see what will go on. And the line number and the character number we also have in the interceptor.
The interceptor, yeah. Okay, that was. Wait. Am I going crazy? No, we still need curly braces.
Yes. So if we have something variable, we need and want to refer to a local field or to some a local variable or a private field or something, then we want those curly braces.
Is it line?
Line, yes.
Yeah, line. And I'm just going to copy this because I believe it's faster than we type in, but I could be wrong. And it's of course not line, but it is character.
Cool.
Looks good.
Yes, and now we need the file path of the interceptor. I think we have touched on this with Jason last time, gave us a hint on how we get that, because I think this will be here, this file path from this node, which will be the method. And maybe we just add this to this interceptor info, or just add a string interceptor file path. And oops, where's the walker? There is the walker, and we just say, well, this will be the tree. And we add here tree.file path. And the other element, now we want that's the symbol info. That's the symbol info. So that's the interceptor, actually. And we also want to pass that down. And this is a I symbol. I think we can cast this to some I method symbol, I believe. I'll just go ahead and try it. I method symbol, I hope. Which means we can also add the I method symbol as an interceptor. All right. And
what is this I method symbol again?
That's from Roslyn. So this is depicting, this is not syntactic information, so that's not a node. Okay. That's now symbolic information, so actual type information. So what we would, if we would have a look at this from a one-time perspective, it would be everything that is in real reflection. And from a symbolic Roslyn perspective, the symbols would be the comparable thing. And it has information such as, hey, is this method an extension method, or is this a generic method? Is this an async method? And all of the information, and I guess somewhere an identifier and a receiver type. I think this is the type that this turns the type that the object is applied to. I'm not certainly sure what that means. Anyway, I guess this should contain all the information we need.
Got it. Okay. Okay.
But not from the node, so not from a syntactic point of view, but from a semantic point of view, what this node actually means and represents. So this is closer to the IL code than it is to the source code.
Okay.
And now we should be able to fill in these gaps as well.
Also interpolated string, right?
Okay.
Oh my god. Wait, I can't find the dollar sign on my keyboard. I'm just gonna copy this line. Sorry, I'm a professional. I often do that with umlauts when I can't find them on a keyboard. Anyway, okay, so we need so wait, the first bit.
This would be the file path. So this would be the interceptor file path that we now added to the interceptor info type.
Oh, okay. So okay, got it. So we need curly braces. Woohoo! Woohoo! And then we need not a dollar sign. We already called this. Oh, interceptor dot interceptor file path. Easy. And did I break something? No.
No. So far, so good.
Oh, it's again, my colors are not updating. Yeah. Okay. It's really annoying. But okay, it looks fine on this stream.
It is.
And what's the second?
For now, let's use the method symbol. I'm also not certain. Let's start with just stringing it, and let's see how we can go from there. So this will be the interceptor property that we also just added.
What? Sorry. What?
I think it's called just interceptor.
Okay,
so
got it.
The symbol that we just added, and let's also toString it. And yeah, let's see where this goes.
Yep.
Let's see where this goes. I expect the test to fail. Object not set to an instance of the object. Well, I didn't expect it to fail because of that. Ooh, something is null. Uh-oh. Oh, indeed.
Yeah,
Something adding here is, ooh, yes. Is this it? Is it the This is not a method. Okay, this is not a method symbol. Let's see what it is. Let's see what it is. It's slow. But also, oh, it is null indeed. Okay, so from this node, which should represent our interceptor method, let's say .to full string to see what it is, and this is our interceptor with the attribute applied, but we can't get a symbol out of this. Okay, then what else could we get? So if it's not a symbol, perhaps we can get an operation. No, I don't think so. Type info? No. Let's give it a try. I don't think so, though. No, this is not a symbol. I'm afraid I now need to do some trying.
That's okay.
No, of course not. What would that be? It's not an operation, is it? Okay, but that's the method body operation. Yeah, that's not too helpful for us. No, we can't get this symbol information. Okay. Now that. Okay. So we can get the symbol info of an attribute, but we can't get it from this method node. What else do we have? Get declared symbol.
Sounds good.
Because there is an overload for that takes method declarations or base method declarations and then returns an iMethod symbol already. That looks promising. So it's not a symbol, it's a declared symbol.
Okay.
Okay, that looks good now. Yes. Okay, I'm just trying to understand the difference because as an attribute, we are using the attribute, we are not declaring it. So if we use something or invoke something, I guess we need to use we can use get symbol. But if we have something declared just as the method, not invoked, but declared, then I think get declared symbol is the go-to. I just briefly want to take a look what else is there. Deconstruction for diagnostic, enclosing symbol, nullable context test, query clauses. Okay, no? Declared symbol. It is cool.
Speculative stuff?
I have no idea. I have no idea what it means.
What is it? Speculative conversion symbol info. Oh, speculative symbol info.
I don't know what the difference between the symbol info and the speculative. Binds the node in the context of the specified location and gets semantic information such as type symbols. This method is used to get semantic information about an expression that did not actually appear in the source code. So we don't have it in source code, but we could create a new node and then see speculatively what the symbolic information about this node would have been if it would have been in our source code, I think.
Wow. That was not only impressive as in how fast you understood that, because it would have taken me probably a day, but also well done for using English grammar and tenses correctly. Love it.
It's interesting. I did that.
Been if it had been.
I'm surprised that I did do this right, because
I don't know if you did it right, to be honest. It sounded right to me.
It just sounded fancy. I think it's totally wrong, because I also use fewer and less incorrectly. Which is like English lesson 101. Yeah. I said, what did I say the other day? It's less. We have less invocations, but it's fewer because it's countable. No, I'm now mixing it up. I did something wrong around there. I shouldn't give any English lessons. No.
Amazing. Now I will forever be scared of using less and fewer. I'll just always use more.
Yeah. Okay. Then how do I then describe the opposite of more? Then I say like the opposite of more, but I never say less or fewer. Excellent. Worked around. Cool. Now we should have gotten rid of. No, this is definitely not English. Yeah, and now we have the issue that I expected, where I said, okay, we will have an issue there because an item with the same key has already been added to our dictionary.
Oh.
Now in our add interceptor method, we always add. But what if we have this value already in the dictionary? Because we have in our test, we have, they're all in the same file path. So we don't have one interception per file path, but multiple interceptions. We have at least one. Well, if there is none, then we wouldn't add it to the dictionary, but we have at least one then in our resulting dictionary. So do you know how we can rewrite this code to add if it doesn't exist, but don't add a new dictionary, don't add a new key, but we use the existing dictionary that we have already added and added to this one? Do you know how to write that?
I would probably do like an if statement situation.
That's a perfect start.
Yeah. Is there like a link situation that we could also do?
There perhaps, but I wouldn't know how to linkify this.
Okay. That interceptors contains. Does that work?
That would work, yes.
Okay.
So this now says, so we now have the if condition if the key already exists. So we know if the key exists, if we would add it, it says key already existing exception.
But we need to add a new entry to the second dictionary, right?
Yes. So we need to now get this dictionary. We need to get the already existing dictionary.
Yes.
Basically looking into the dictionary and extracting that information.
Yes. Right.
We could.
What do I have?
Yes. We could one solution could be via an indexer. Because the dictionary has an indexer that takes a key, in our case a string, and then returns the value. So it looks like an array indexing, but it is dictionary indexing. So it's the same syntax, but different semantics.
Okay. And we're still talking. Oh my God. Easy.
Aye. So we index into the file path, we get the value and add, and this is correct.
Drum roll. Working hard or hardly working.
We just need to put this into the else block and we're ready to go.
Oh yeah? Yeah, else block. Copy paste? No, I'm even cutting this time. Wow. Did everybody I still have to sort of like watch my fingers because I don't trust myself to copy paste correctly on stream. But yeah.
So, okay. So we now have those 3 elements, but we now have some inner exception, actual and expected. So yeah, so the format isn't 100% correct. Okay. So we do not contain, we only have the method invocation. We only have the method, not the type name that this method is in. So I guess we need to add that.
Okay.
I'm a little bit uncertain how to do that though, but let's find out. And I am always at the wrong location. It's here. No, here. There we go. Okay. So here, just toStringing the node does not suffice. We also want the type that this node is in. So I guess we know, actually, we should be able to cast this to a method declaration syntax. And maybe now this node also contains information about the type that it is. Return type, it is enclosed in, or is that only symbolic information? Because from syntax, perhaps we don't know. Parent, that's the parent node. Perhaps the parent would work. If we toString the parent, just give it a try here. Let's see if we say node.parent. I can imagine there's a more elegant way, but for now.
Do we need to toString it?
It would, we see this is also a bit grayed out here. It implicitly toStrings it.
Cool.
If it's not a string. Invalid cast. Ooh, it's not. Okay, so this is an identifier name. Okay, now from that we don't know this information. Well, if you're fine with it, this could be something that we take care of later on, because that's just like fiddling around with the Roslyn API to get that right. So for now, let's omit that. And oh, yeah, I forgot the third one. And the next one is okay. Now, almost there. So, oh, did I just miss something here?
Yeah, this is a bit
generated. Yeah, I haven't. We also need to expect the type name. So we only have namespace and method. Well, this doesn't work. We also need a type name that those interceptors are in.
Got it.
Ooh, and it's green.
Wow!
Cool. Cool.
Lovely.
And I guess it's now time to use this information and put this into our tool, because we would like to test this tool then against this web application that we showed in the beginning and see if it's working against a real project. Okay, so what we need now is very similar to the using command that we previously built. We need a command for our interceptors and add options and arguments if we need. Set a handler that will then invoke eventually our API, our interceptor locator.
Yes.
So this will be, we will have here a new document, interceptors. So yeah, basically listing here our existing commands. Now we need a new command. Yeah. So let's start with a new command.
Oof, I love naming. Those are always like the longest discussions. Okay, well, we know how it starts. We wanted to start with flash or where, right?
Well, we already have that. We already have the root command. We already know that. That's cool.
Oh yeah, but for you
I will add a new
right as well.
public void add interceptor commands or something. Which I'm just now go peek how we did this in the using directives. In the using directives we call it add using command, and we get in the root command, just putting in all the stuff we get in there as well.
Okay.
So this will be add interceptor command.
Okay. Add interceptor command.
So let's now create a new command.
Yes, let's.
Would like to go ahead?
But can I peek again? I don't know how to.
Well, let's. How would you create a new command?
New command.
And this command takes a name and a description.
A name and a description. A name and a description.
So what we currently have is, like on the same level, we have the using command. How would we like to call our interceptor command? Maybe interceptor? To name the feature.
No, but I'm still not sure what I'm writing right here now. Because is the command? Do we just have to declare the type, or do I have to name it, or do I have to?
Oh yeah. We still have to give it a name, something. Like, you mean that?
Yeah.
Yeah.
Oh.
I guess we could call this now interceptor command.
Got it. Okay. Okay, and then this command takes
a name. This will be the name that we enter via the command line. So like using here.
Oh, it should be a string then, shouldn't it? What did you say? Did you say intercept or interceptor?
Interceptor. Or do we call it intercept? Do we name the feature, or should it be a proper verb?
Oh my god.
Or do we use a proper verb for a command? Because I think they should be verbs. Or do we name the feature?
Yeah.
Because in here, using is not really a verb either.
What?
Oh, is it a verb? Or is it a noun verb? Verb noun? Oh, my English.
Wow. Yeah, I can see what you're saying.
So maybe we use here. Maybe we use here just to be in line or in sync. Let's use the feature name here, and then for the subcommand where we now whatever we want to do, because we could end up, or we will end up with more interceptor commands. Just with our using, we have count and globalize. We will have more interceptor commands as well. So we will have more subcommands to these interceptor commands, which then should be verbs because they will be executing. Things.
Okay.
And a description.
And a description, which is also probably a string.
Say, I don't know. Let's start with C# interceptors. Or experimental C# interceptors. Perhaps we should to keep that to surface that it is indeed an experimental feature currently.
Like
cool.
Okay. And then are we done, or do we also need the curly braces and?
No, we don't. We don't need to initialize anything more. But now we need a new command, which is now the verb that we want to do. Now comes the tough question. How do we call the verb?
No, come on.
Well, really? We can change variable names. That's easy. But for now, it's good.
And it takes a name and a description.
No idea. how do we call that? What do we do with these? So the type, we called the type intercept. What we currently have, we can change this. Definitely, it's still in a branch, and also it's our internal API. It is very changeable. Interceptor locator, and there is a list async method. Current name, we will change that, or could change that. So what would be? We are going to visualize. Will I find? Yeah, basically this. How would you call the action of displaying these, or listing these, or locating the interceptors?
Some very good verbs there. Also, like, what is it? Okay, so either we can go with the action, which is sort of like find or locate, or even like maybe potentially expose. I don't know. Or we could go with the result, which would be something like list or
I'm not
show.
sure.
No.
No, why not? I'm not trying to look into. Okay, well, what we just entered to basically list all available templates. That's .NET New list. I'm not trying to find what else do we have. I think we can also display global tools that we've installed. So that's tool. How do we do that? Okay, we list tools installed globally or locally. What else do we have? Now I'm wondering if I only find options that support my favorite, that is obviously list, or if I'm really searching for what would be the most expected, the verb with the least surprise in the .NET SDK. What else do we have? One SDK. Well, even the search. There is search, isn't there? For .NET Tool also has a search. And I think that actually searches on NuGet.org. So what is available? Okay, so we don't search could also be. What do we have for workloads? .NET workload. There is an install update list search. Okay, so list seems to be local, what is currently available, and search is what is available on the web. So I have the feeling that search also has a search string. So what are we searching for? So I guess list is unconditional and search is conditional. We can also list.
I think list is I mean, even for somebody who's has as little experience as I do, it is sort of like a very natural command. It's something that it's something that is I think one of the first commands I ever learned or heard or used or remembered. So I obviously would. I think it's definitely a good shout. The reason why I sort of also I want to try one more train of thought, which is again expose is also not the right word, but what I liked about it is that we sort of show something that's usually hidden or tricky to find, or as we said, like it's actually quite a pain to figure out. That's what it does, like sort of make something visible that's not so visible.
I have the feeling that expose also has a side effect. If I expose something, it's also visible to others. But we don't manipulate anything. We don't.
Yeah.
So this is why I am not leaning towards expose.
Got it. List.
And list seems to be side effect free because this is what our command is not causing any side effects at all.
Side effect free way of listing interceptors and no. What would you say?
Interceptors,
Yeah?
Yeah.
Should I get rid of that and just say lists? Interceptors.
Okay. Now, what do we need to do next? Now we need to set a handler. So, okay, no, hold on. Now we need to add. Ooh, excellent. Yeah, definitely. I guess we cannot stress it enough. Yeah. Mm-hmm.
Good.
I like it. Now we need to add the subcommand to the parent command. Or basically, no, we need to add we need to add the subcommand to the parent command. Interceptor command, yeah. And now we need to add this parent command to the root command to make it always append it to our tool. If we do, so I guess I still should need to call this method, otherwise this won't be fun doing nothing. Add interceptor command. Oh yeah, there we go. And hitting save and doing a .NET run on this. Now yeah, we have some warnings to take care of, but this will be done later. .NET run .NET 7 -- let's run help. And we see the interceptor command. Cool. And let's run intercept to help. And we got, yes, there it is. And we have the list command, interceptor list. I guess this currently doesn't have, yes. Okay, we don't have any arguments. Now we need to make this invocable because currently it does dramatically nothing. Okay, that means we need to set the handler to this interceptor verb.
Okay. Where's the handler? How do you get the handler?
Set handler.
Set handler.
So that's a member method on the command, on the interceptor verb. If I recall correctly. I also go cheating to the using directive. Oops, sorry. You were in the follow mode. Sorry. I'll just grab this code here.
Yes.
I'm gonna use it later. So there should be some set handler.
Set handler, woohoo!
And set handler now takes the invocation. So we have an action. So we will define a lambda that has the invocation context as an input. So we can say context goes to, and then define the body of our method.
Context like this, yeah. Goes to, and then I didn't hear what you said.
I just no, that's good. I'll just paste in what we have for the
got it.
For the using command. Well, we currently don't have any arguments, so let's get rid of these. We still need the project, so let's also add an option. Let's add an option project. But if you don't mind, because we wrote this like several times already, I'll grab this from here.
Yep.
But we still need to add it to this verb command.
To the verb command. And when do we need to add it? Actually, at the end. Can we do that? Sorry, I'm confused. We need to add the option to
this list command, which is called interceptor
verb. Okay, got it. Oh no, that's not what I meant. And then we need the project option. Woohoo!
I think there's also a method that's called add option. No, I think this is doing the very same, because there is an overload because there is an add method a method group that has an option and an argument overload, but these also exist as like direct add option. And so there is no difference. What do you prefer? Say add or add option. The effect will be the same.
Add option.
Then with our handler, okay, so we get the project. Well, we do the same logic from previously. We find also from the current working directory and so on. And now we need to invoke our interceptor. No, interceptor locator.list. And this one takes a project and a cancellation token. Project. This will be where do we get the project from? I call this, because this will be a C# project. Need to get this, and also the cancellation token. Then we pass those two. We will have a result. This will be the list. And then via the context, there is some console to which we then can write the output.write lines and so on. Okay. But first we need, where do we get the project from? I think this is done via the workspace, because we will ask this MS Build workspace that we have to open a project. Would you like to give that a try?
Yes.
Because with the workspace, we can open two things, either a project or a solution. We currently don't support solutions yet. We're only on project level.
Open project async.
And this one takes a string to the project file path.
Okay, but we've got
a file info.
Yeah.
But the file info is a property for the path.
Path.
And I'm not sure about the name actually. Something with full.
Oops. Oh, nice. Full name.
Full name. Because there is. Oops. Excuse me. Excuse me. So there is. There is also just a name property, but the name property then would be just a project, like myproject.cs, but we need the full file path. So now we have here an async method. How can we get the project out of that result?
We need to await it. No?
Yes. Oh no, not here.
Not here? Oh, wait.
We need to await because what is awaitable? Yes, so a type is awaitable, and in our case, this task is awaitable, and then we'll produce the project as a result. That means we need to make this also async. No, hold on, not this, but the callback, the handler. So we can also make an anonymous method or lambda methods. We can also make them async.
Interesting. Okay. Oh, easy.
Okay, cool. And the cancellation token, I think the token we get from the context. Because this context from the system command line context that does the hooking up with the keyboard signal termination like Control C and whatever there is. Cool. And now we just need to print this result. Now on the result, okay, we just get a task of interceptor list here. What do we need to do in order to get this result? Because we only have the task.
Can I just say result dot and see?
Yes.
Okay. Let's see. We can get.
But this is not the information of the task.
No.
We need to do the same as with the project because we only have the task of it. This is just a promise that it will return this task. This will return an interceptor list. How can we actually await this project? Yeah. So I'll be just putting await here.
Oh yeah. Okay, sorry.
So we can now change this into a interceptor list instead of a task of interceptor list. And now,
got it.
now we have the true list available. And I think the only method that we expose on there is the enumerate. So we could now, for each, so we could invoke enumerate on this result for each it, and then print the information to the console.
Okay. And we can probably do that all in one line right here, but I cannot. So
no, we need multiple lines.
Okay, easy peasy lemon squeezy.
Because we will have multiple, we will actually print multiple lines. So we will invoke white line multiple times. This is not a one-liner. Well, it could be technically. Actually, you can put an entire C# program into just one line. It's very horizontal then, but it's possible.
Why does this not want me to?
Because result is not result itself.
But it's a list.
No, well, we call it interceptor list, but result actually itself is not enumerable. We only have the enumerate method.
Yes. Can I just do it like this?
Yes.
Oh, wait.
And
easy.
There is let's do later on. We will do this without calling enumerate explicitly. We can use some C# pattern to actually make this enumerable. Without, well, we could make this. We could implement IEnumerable here, and then make it. But it also works without that. But we will figure that out.
Got it.
And once we got it running. And now what we want to do is basically having 3 console write lines to print this information that we, in the format that we intended. I'm now searching this comment. So we will have the first line will be just a minus with the file path. Then we have space minus with the intercepted, and space minus with the interceptor. And this should be it.
Okay, so this sounds like string interpolation. Oh no, but I can't copy paste the $. No, I actually need to look. Oh, I found it.
I'll write it for you.
Oh, but I just found
it.
Right. And then, wait, we need a minus, you said, first. And then we need some curly braces. And then we need something from the interceptor, which is the file path, right?
Yeah.
And then in the second one, we need 1 space, right?
1 does,
or
yeah.
2.
Or 2.
Right?
Yeah.
Okay. And then some curly braces. And then we need the interceptor. What do
this would be
now?
not intercepted. I think we call it intercepted on this type.
Yes, we did. How do you remember that? I would always have to go cheat. Okay. For me, it's still okay. It looks fine on your end. And then we need 2 spaces, 1 minus, curly braces, and then we need interceptor. Interceptor.
Cool. I'm afraid what troubles me here is that we access here public properties, but they start with lowercase. So we want to change this. We want them to be uppercase. So everything that is not private should be instant. Everything that's not private should be uppercase. Well, it's only private fields that begin with a lowercase character. Everything else should be uppercase. I may be now missing some corner case, but public properties or properties in general are uppercase.
Okay, but we should change it.
The thing is now, if you don't have to rename refactoring, because I'll do this on my end because I do have to rename factoring. So just go ahead and rename these. So this is actually the only exception where you write
Ah, because the method is called...
Yes.
Interceptor2 it is.
Call this into interceptor. What would be the combination of the file path info? We already use interceptor info somewhere already, so I would like to avoid this ambiguity. Interceptor data, interceptor record, interceptor entry details. And this is the only exception where you have an argument list. Hold on, that's a parameter list, my bad. A parameter list where the parameters start with uppercase, because what the compiler is creating behind the scenes properties which have exactly these names, so they should be uppercase.
Why is it the warning or whatever it is? Because I don't actually see that on my end.
Right. I think that would like it to have the P, like so, file path.
Okay.
Because it's 2 words. Cool. Okay, and now let's try to run this against our very web application here.
Don't we need to change the method? Oh no, you did a rename, didn't you?
Yes.
Okay, got
so this should compile. Let's see if we can still run the tool here and if we run it, now this should say something like project not found. Interceptor details does not contain a definition for file. Oh no, actually something did not compile indeed.
The file path.
The rename refactoring did not work at all.
Okay.
Visual Studio has betrayed me. Has betrayed us. Now it compiles.
Woohoo!
I was hoping no.
Okay.
This is. I'm uncertain. Nothing. That's little. Why is that? Because it tried. I think, because we don't explicitly state it a project. So I think since the current working directory is where we have a project, so it tried to apply it to itself, but there are no interceptors.
Easy.
So it did something. Now let's dash project and give the path to that CS proj here. Copy as full path. Control V. And I think I need Camden to cancel build. Okay. It does nothing. Damn it.
Why?
It does nothing. I don't know. Let's
debug.
Yeah, but the question, how can we? Well, I guess so. What we should do definitely is now write an integration test that replicates this very scenario, but also in the respect of time. I don't want to do what you mentioned earlier. I have another 4-hour stream in the respect of time, so I'll do something hacky that we will definitely later on put this into an integration test. Absolutely, because this is otherwise the pull request will be denied, won't it? But what we will do now is basically quick. Oh,
does it? No. I'm trying to say smart vocabulary that I learned on this show.
So well, is it really tech-dep? Well, I guess missing tests could be. If we would never write tests, we would accumulate eventually tech-dep. Yeah.
Okay.
Because a lot of stuff would be untested and undefined, more or less. But in our case, I think it's, not sure if maybe tech-dep is the right word. I definitely use tech-dep wrong.
Okay. I don't.
0 tests means 100% coverage.
Nice.
I'm not sure. Okay, so passing these arguments manually so that we can F5 into this application. I hope that the working directory is all right and everything. But let's see if we do enter this very command handler. Isn't that how it works? No, I think no test at all means, I think that's 0% coverage, I'm afraid. Okay, so this is now giving us file does not exist. Oh,
okay.
Getting the error here, file does not exist. That's interesting. That is interesting because should it not exist? I'm not copying it from the copy as path. Oops. Breakpoint. Program. Oh, yes. Okay, there was something bad going on with the insertion. It tried to. I'll try to use the. How can I? There is a power to control Windows V. I want to insert this verbatim. Okay, I think this does it. No, there is too many. Okay, now it should be. Now it should be path. Right path. Ooh, speaking of code coverage, in the next season, we will definitely have a session on code coverage, how to calculate it, how to display it, and then actually see how good our code coverage is.
Uh-oh. That sounds scary.
Indeed. Ooh, that looks good. Web application. Okay.
Yay.
Let's see why our enumerate is indeed empty, yielded no results. So what is going on in our interceptor locator?
Yeah.
Maybe it is something that, well, it could be. Jason mentioned two things last time. Either maybe this file path doesn't exist, could be, or we need to maybe we don't find with the method that we do here. Perhaps we don't find the generated code and need to do something different than to find this generated code that holds the interceptors. So it may be one of these two things.
Why would the file path not exist?
Let's see where we go. Okay, so if we visit that, we actually, after visiting that, we just don't find any interceptors. Okay. That's. Ooh, hold on. Okay, this may be 100% my fault, because what we did in the
that
demo.
That means it's 0% mine.
Yes, 0% yours. Because we did set publish ART to, well, because now no generators is available. Indeed, because we changed that. Now let's bring the generator back. Okay, so we don't display anything if none are found. Okay, perhaps we should then display a string. Okay, none found, but that's a bit of an user experience improvement. Now the request, it's there. Here's the generator.
Okay.
Now I'm getting nervous.
Okay.
File path exists. Still didn't know. I'm looking here at the command line output here. It doesn't list anything. Let's do some breakpointing. Do we still not find any interceptors? We don't find any interceptors.
Oh no, it would have been too easy.
But why? Oops. There is the walker. So our syntax walker does not find. Do we not find? Let's see if we enter here. We do. No, that's the. Oh, we don't. We don't. So we can't visit any of these. We don't even get in here, do we? We're not hitting this visit method declaration syntax. But not any. We don't find any method declaration. That is troubling me. Let's add to this project. Well, there is no method declaration, is there? Let's add something. Maybe it is indeed that we can't find those generated documents. My class. And my class has method in it. Let's see if we find that at least. So if we technically would find methods at all.
Okay.
Oh no, hold on, wait. Maybe I was too hasty. We have 2 documents. Yeah, the generated documents are not part of this here. Okay. We have the my class and the program, but we don't get the generated document.
But why not?
So maybe this is what Jason mentioned, that we need to compile it somehow with the generator to get these. I'm now wondering if there is project.
Okay.
Get source.
But
there is a method called get source. Yeah.
Get source generated document async.
Get source generated documents async. Maybe we want to do that too.
Yeah.
So you were about to say?
I was about to say that we are in our globalizer and counter. Well, we did want to exclude
generated documents. Yeah.
Documents. So I was just gonna go peek
what
we did there and then use that logic to get to them because we got
yes. Well, but what we tested it against are generated documents, and generated documents are just documents that end with .g.cs. And so that means if we would just go ahead and basically define our own generated document, so that is available as a source code. I call it my generated document .g.cs, and also adding this auto-generated comment. Now, this is what we did. We basically wanted to include .g.cs and documents that have this auto-generated comment on top. So documents that are generated by any means. If they are generated by a source generator or generated by some other tool, because before source generator existed, you could have a custom MS build task. That is when you build your project running and creating new source files and adding them actually as physical files to your project. And then you also get this auto. For example, this is in the company we worked together previously. We had some Swagger definition things that generated HTTP clients for us.
Okay.
If you can recall that. And this was not a source generator, or not a Roslyn source generator, but some MS build task that created new documents. And we then had some folder where we put them in, and still they were set to auto-generate it. We could manipulate them, but when we build again, this will be refreshed because the generator will create them anew. So what we excluded is all auto-generated documents. What we didn't know at the time is that it seems that source-generated documents, so documents that are actually created by a source generator, are not part of these documents. But I'm hoping that they are here. So what does the... Okay, that's document. Let's get documents. Okay, cool. And this will be a collection of source source-generated document. And a source-generated document is also a document. So what I'm hoping now, can you recall the one link method that I didn't want you to use earlier?
No.
Append.
Yes.
So we can now, oh, that's not, why can't we? It's an enumerable of documents, and we want to, because a source-generated document. Oh, yeah, I need to await that. That's async. My bad. Oh, no. But still not. Damn it.
Sorry, so what are you appending it to now? To the document? Or documents is
to the documents is an enumerable of document. I was hoping to, via link, append these.
But do we need to go? Oh, we do, don't we? No, I think I confused myself now.
Because
well, can we just go through Gen, like through the?
Yeah, let's do that for now. I mean, we also want to go through all documents, because technically you could write your interceptor manually as well. So we definitely want to also have, because
just code, write it twice, 2 for
but
each.
You know what? Let's try with that for now. You're 100% right, but we do want to do both eventually. But let's see if that already works.
Team. Failure.
Unable to optimize assemblies. Okay, but this is just, okay. But it's just a warning. I think what we also need to do, we have to set 2 locations, don't we? Oh. Go through documents here again.
Yep.
Source generated documents, async, await, gen. And let's debug and see if we hit that. I didn't know that there is a means of. Is this empty? Is this empty?
No.
This is empty.
Okay.
But what now? Okay. What could be the problem now is that which SDK are we using? Maybe we are using, because we do get this warning that because we're having here .NET 8 project, but we are not using the .NET 8 SDK just yet. Okay, let's try to upgrade to .NET 8. Okay, we have a. Let's upgrade to .NET 8 and see if this is helping.
What do we have?
I just set it to .NET 8 now. To be only .NET 8.
Oh.
And let's see if that does the trick already. Let's upgrade the. Well, let's not care about the tests currently. Let's just see if it works. Then we later on do proper multi-targeting and everything. But for now, let's just try to get it working. I hope this now selects the correct. SDK. Because if we take a look at here, when we launch the application, there were build errors.
Oh, wow.
Yeah, those are the test projects. Yeah, let's upgrade for now everything to .NET 8. Target framework, of course. Target framework. Target framework. And target framework. So I guess, okay, so I guess...
That works. You still have works then.
Oh, thank you. Reload faulted project. I guess then our tool should handle this and see if we're using a... And now I'm in a Visual Studio doesn't support that yet. Okay, great.
Oh my god.
But we have the experimental Visual Studio version ready. Just switching to a different Visual Studio now. Whoop. We're so close, I hope. I think.
I'm confident.
Launch. And we launch the tool. Yes, please. So now launching the same tool, but in the Visual Studio Preview, which does support the .NET 8 SDK. And Acquainted Training's joining. Hello.
Thanks for joining.
We will have a link question in just a minute.
Yes.
Error TFM not implemented. Yes, indeed. Yes, indeed. Okay, just some conditional compilation. Not worry too much about that. And Stuart is here. Hello, Stuart.
Hello. Oh my god. The whole gang.
So we are currently trying to get our application, upgrading it to .NET 8 so that we can compile an ASP.NET Core native AOT web app and receive the interceptors of that. That sounds hard to follow. Okay, let's see if that did the trick. Which MS Build version have we now selected? Ooh, that looks good now. So we have .NET 8 SDK selected, which should now be able to build this project with the right SDK, then use the source generators to produce the interceptors, and then maybe list them or not. And
oh my god,
we receive generated documents.
Lovely.
But those are not containing. They are not containing the generator we expected.
Why?
So this will still be empty because okay, this is maybe the problem is because it could be, I'm not certain. It could be that this project is using Microsoft.net.sdk.web. So that's an SDK particularly for ASP.NET Core applications. And those are different to the SDK that we currently use because that's just the default .NET runtime, Microsoft.NET SDK. So not the ASP.NET Core, but the default .NET Core SDK. And maybe, but that's just a runtime, not the SDK. Is that a problem? Because we do get generated documents.
Yeah.
But I don't think we get generated documents that are related to ASP. We do have JSON serializer generated documents. This is good, but they are part of the default SDK. They are not part of they are part of the SDK, but those generators from the ASP.NET Core, particularly this is an ASP.NET Core generator. So maybe that one is just missing. And I would not know how to open that project. Oh, maybe are we hitting a what's it called? Roadblock. I'll be sad. How do we open that? Because we opened the project here, we had a workspace.
Yep.
How do we teach it to use the web SDK? I wouldn't know how to. Not at all.
So, okay. Not open as or open with, like in File Explorer. Would be nice.
That would be nice indeed. But we only have open. We can open a document. We can open a project. We can get documents. We can open additional documents. Wait, what if? Okay, what if?
Yeah.
I don't
What?
think this would be. This also sounds hacky. What if we were using the Web SDK for our project? I don't think this would solve it, but let's see. Oh no. Yeah, okay, now it's a web application. Okay. Yeah, this is not the solution.
Okay.
But now I'm curious.
It's called JSON.
Yeah, I guess we need some more misbuilt help. No, still not. So we do get generators or generated documents, but not the ASP.NET Core generated documents. So maybe our project can only be used for generators that are. Would it work with third-party generators? Now this is what I would like to, but we don't really have an. I'm wondering if there is a third party, like a NuGet package generator already, that uses interceptors. No, I totally don't know.
And how would we know if the NuGet package includes interceptors? We wouldn't, would we? We just have to read through the code.
Yeah, pretty much.
We're not doing that. We can do that in our 24-hour episode.
I actually do want to experiment and write one, but I do not have that one ready. And this is not particularly a 30-minute task. So I'm running out of ideas how we could get this ASP.NET Core web application running. Is there maybe a different way how we can get a hold of the project? Maybe the workspace. Or does the... So where's the workspace that we create? That's here. No, that's not here. That's here. Do we have to set some... Maybe we have to set some properties that ASP.NET Core expects. Oh, I really don't know.
Okay.
Or some host services. I really don't know what these are. Oops.
Oh.
Oh, I think those are for custom drivers. Okay, can we ask, do we have ChatGPT here? Or Copilot is enabled? Not sure if I've never used it really. Open Copilot.
I've never used it.
Oh, that's open ASP.NET Core project in MS Build workspace. Austin. Maybe that's Bingable.
Bingable.
Yeah, but that's just the good old. So what's that doing? So I need to give it some information, don't I?
I guess so.
Like, make this work. Open an ASP.NET Core project via the MS Build workspace.
Is that how it works? You write a comment?
I really don't know.
Okay. Jim.
I thought some demos, what I can't recall. Zero solutions. Nah, definitely using it wrong.
Copilot gave up.
Also, I have absolutely no idea how to do this. Okay. Wow, does anybody from the audience know how we could work around that? Not work around, but utilize that. So we did find out that in the project documents does not contain source generated documents, but we can get a hold of the source generated documents, but those does not include the ones from this one actually that is here. This one. We want to get this one and have all of that information. Unless the publishability is true. Wondering if there was anything else we need to set. It should load this from here, shouldn't it? What do we need to pass these? Like, but there is so many other analyzers and generators.
Is there like a way to figure out how this get source generated documents async method is working and then just write our own with
maybe. So there is okay, so the solution has this seems to be eternal APIs. Well, there is a there is a C# generator driver.
Okay.
And we can create our own C# generator driver by giving it
the
source generators. But we do not, how can we get the instance of these source generators of that project? So we would need to get those types. I don't think we can get a hold, well, where would those types be available in the compilation? So if we take a look at the project and get the compilation.
Yep.
And then ask the compilation for, how does it work? Get name, get type name, get type by metadata name. So we're now asking it to give us the type from this generator. And I think that this is the name Microsoft.asp. I can't copy that, can I? Microsoft ASP HTTP request. Is it maybe in this? Copy full path. Maybe that's part of the, because that's the name. I don't want to do any typos. No, that's not how it works. Well, we could go to the the solution, maybe source.net in the .NET source browser and get the request delegate generator. And we get a hold of the request delegate generator by, let's just find this one type. I guess I'm not even know if this works, but if it would work, we could just ask for all of the types and get all of them. So we ask this, please give me, sorry, well, there we go, this type.
Yep.
But I'm quite uncertain if this would work. but let's find out.
Yeah.
Also, perhaps we should change this back into a regular application. It's now.
Okay, great.
But this would have been cool. Reload, please. Yes. This would have been quite cool if we could get the type. Can we get from the type? Can we get all of the types? No, we can't. But this would be one way, but we can't get that generator. And because that's not it's not a one-time dependency, but a compiled time, a development dependency, compiled time dependency only. So maybe that's not part of the compilation even.
Okay. Well, what is it part of?
If I would know that. Get generator types from compilation, Roslyn. Well, there is a way to get all of the types. Symbol visitor, and we get all named type symbols, but I don't think this would work if we can't find it via this method either.
Yeah.
Okay. Yeah, but if we would have received those types, we could just get all of we could scan the entire compilation for all types, ask if they are generators, and if they are, then create a generator driver for that, and feed in the where is it? Feed in the parse options and somewhere is a compilation. Can't find it right now. Oh no, hold on. Then we create this driver. Let's say we have the generator here. And then we can say one generators and update compilation, where we put in the existing compilation as an input and get a new compilation. And then from this new compilation could get the generated documents.
Wow.
Yes, this could have worked if we would have gotten this generator. But Stuart is asking or suggesting, we're using the MS Build locator. Yes, I presume that you would need to select the .NET 8 MS Build if you don't have done that already. I think we did. Because, well, we now upgraded all of our projects to .NET 8 actually to force that. And if we run into our code and debug that, this shows that our MS Build locator is returning 8.0.1 and also understands that this is from Visual Studio installed, so that looks good. But that gives me an idea. Maybe let's update all of our dependencies.
Yes. Good shot.
Looking good, thank you. But thanks for the feedback. Okay, let's just update all of it. And perhaps we need to go. Wait.
Why are there errors?
Okay, I think the order is critical. But let's actually go with this one too. Let's include pre-releases. Because maybe this MS Build workspaces locator is in version 2 old. So let's use here the latest. Maybe. We have a conflict. Resolve this issue because NuGet issues are always fun. We have some mismatches. How do we best fix that? Perhaps if we set it manually, 8 for 80, 3 point final. So let's find, we don't have any dependencies here. Here we have 8-3 point final. Let's set this for all, because we would need, I think we would need to set them in the correct order. Otherwise, there could be, if there is some package downgrade detected or some mismatch, then NuGet says no, because this then could crash terribly at runtime. If we set them manually and then build all at once, then we would, I hope that we don't run into this ordering issue. Oh, there is one more. Should be good. Okay, we do have one. Okay, we still have one version conflict in core tests. Maybe it's from this reference assemblies project. Okay, no, we do have, it was not found. Oh, Microsoft.NET Test SDK. Oops, I think I updated the wrong one as well. Yeah, this is wrong. This is something else. This is Visual Studio version 17.7.0 or something.
Wow.
I made a mistake here.
I love the
because then it installed. Not sure what the default is. If it finds a package that is not found, well, if it searches for a package that is not found, I'm not sure what the fallback strategy then is. Let's also use the latest pre-release here. Well, that's a test SDK, that shouldn't matter, but let's update all of it. Yes, please. Yes, please. And here as well. Okay.
Okay.
Okay. We just have our nullable warnings, but okay. All updated. Still kind of doubting it, but let's see.
Yeah.
So we still have the 8.0 selected. Oui.
Uh-oh. What happened?
Method not found.
Oh. Okay.
Oops.
Drum roll.
There we go. There we go. Firewall TV suggesting looks like you could benefit from a central package management. Because with central package management, you basically can get rid of the versions in each and every CS project file and just put this into one file, and you just then say include a specific package reference, and then it will be the centrally defined version. And we then only need to update at one location, and that's a great idea. And I'll put this on a list for a future episode. Central package management.
Perfect.
And unfortunately, the drum roll went into. Well, we have an exception though. Is this good? Okay, the one generators. Yes, I didn't want to invoke that, did I? That's in the locator open project. That's in the locator, is it not? Sorry, one key. Yes.
Yeah.
Hold on. Why did it say method not found? We just tried to add. No, there's something else going on now. Isn't there? Is there? Oh, we still crashed dramatically. What's that?
Oh,
okay.
no.
And none. Razor. Razor compiler. Okay, this may be actually generator one generator. We don't have any generator state in our code, so this may now we may now fail compiling the ASP.NET Core project. Because it can't find this method. I don't know what then are we using, but we are now using the latest version of Roslyn, which I can imagine this ASP.NET Core application is also, or the SDK that, because I think we fail here when we open the project.
Okay.
Open project async. I think we fail here.
I think for the next season of streams, we also need like a little rubber duck hat for me, because like points like this, I'm like completely like, you might as well be speaking to a rubber duck. I have no clue what could be the problem.
Well, I apparently only have any idea either.
No, but you come up. You've got suggestions. I had like 2 when you're like 20.
Well, this is. Yeah, well, this is Roslyn stuff. This is no. Actually, we fail here when trying to get the source-generated documents. So this didn't fail earlier, but now we fail.
Okay.
But this may still be related to not being able to. Does it fail here? It does fail here, yeah. So we can't get a hold of these generated documents. We run into here. And let's say, what do we have here? Project.documents. But yeah, I'm totally running out of ideas now. This is some in MS Build land.
Yeah, okay.
So when we try to get the generated documents, I think this may now run the generators. But there is some dependency problem there. Get source generated documents async. Does I get compilation async under the hood or uses the cached results? Very odd that you're getting the runtime exception though. Some razor thing. Can we update the tooling? Maybe. No. Is this? I don't know. Damn it.
We did so well in the first half of
oh yeah. Well, we can say, okay, our tool only works for.
Yeah, but we can't test it, can
like
we?
for SDK like for regular SDK generators, but not for ASP.NET Core web applications.
Okay, but do we know that it does that?
Well, do we? No, we don't. But I would. No, we don't know. But I would think so, because what we previously got from get source generated documents async, we did get source generators that are included in the in the BCL, so in a regular Net8 project, or in a regular, from the regular .NET 8 project, we did get these. So okay, the question now is, maybe this is some problems related to the web SDK, and it would only work for projects that are not web SDK, maybe. So I guess the next step would be to write our own source generator that does create interceptors. I think I'm now nerd sniping myself into my weekend project that creates interceptors and then test it on a regular .NET SDK project and not on a web SDK project. And then it could, maybe we then get here these generated documents, because if we do, these generated documents are, well, they're actually source generated documents, but they do inherit from document. So the rest of the logic should just, well, fingers crossed and knock a lot on wood. No, touch on wood, I think is the English expression, to then get a hold of all of these interceptors and list them.
Okay.
So, well, considering this will be my weekend project, perhaps there is a follow-up for our next session.
Yay!
But if that would work, I think we would be almost there. Unfortunately, we currently I don't have any source generator at hand that creates interceptors. But in our test set is not using interceptors, not using source generators, it does work for other through non-source generated interceptors. Okay.
Okay, but we did manage to sort of clean up the output a little bit and did a nice sort of assert in our current tests. So we did make some progress.
And we did add the command. So
and we did add the command.
We did add the command, and also with documentation and everything. Well, not with documentation with descriptions and everything. Yeah. So this would be, well, if it would be working, I think it would be push NuGet package and such. But yeah. So is this now a web question? Is this a web SDK issue, or is this a source generator issue that we run into in general? But I'm kind of think it's web SDK related, because the exception does say something about Razor, which is a very web SDK thing. But also I am dramatically spitballing or guessing here. Have you looked at Buildalyzer? It shells out .NET MS Build, passing a custom logger which talks back to calling apps to sneak a look at its construct a Roslyn workspace. I believe I only understood half of it. Should we give that a try if we can get something with Buildalyzer? I think, Stuart, you need to guide us here a little bit. Buildalyzer workspaces. I'll put in the comment again so we can. This looks promising. We can get a project, build it. Well, let's try it.
Yeah.
What's license? MIT. Okay, cool. Oops, wrong project. There we go. Let's install the Buildalyzer workspaces.
I like the name. Kind of like the globalizer. Isn't it?
Yeah. Cool. Okay, and now, so the Buildalyzer is using a earlier version of Roslyn. Does it mean we need to downgrade again? I guess this is best done if we just revert our. But I think we were using 4.5 earlier. But why is this not? Oh, maybe because it's a preview. Maybe it doesn't do well with the pre-release. So let's perhaps use the latest. Let's switch to 7.0. Maybe this does the trick. Oops. Control B. And let's try to, you know what? Let's grab the package reference here. We can just copy it into the CS Proj. We don't need to go through the UI and see if that builds. That looks promising. And let's take a look at what we need to do. We never used to build Analyzer before. I'll just copy this code here and see what we can go from here. Analyzer manager, get project. We can analyze the project. Logging was in workspaces, get project, get the workspace, turning it into an ad hoc workspace. And we can add Analyzer manager. Okay. Let's see. Let's go to our. Okay. Let's go to here. Analyzer manager. Do we know the project? We do. Project.full name. And let's see what we get from here. Build error. Yeah, okay, we still have a version conflict. Why do we have a version conflict here now? To test the tool. Version conflict. Okay, hold on. The build. So the build analyzer is using 4.0, but we have, since that's it. Okay, I think we just need to explicitly state our. Hold on, wrong project. This one. Explicitly state workspaces dot. Is it C# dot workspaces or workspaces dot C#? I think C# dot workspaces. Because we had no. Oh, that's the tool. That's the tool. Okay, we need to specify it here. Let's copy that. Oh, I guess I should read the error. So what's the actual error? Okay. So in our tool refers to CLI, and CLI refers to workspaces 4.7, which refers to common 4.7. But the build analyzer refers to Visual Basic workspaces 4, which now have common 4. Okay, so is the common the problem? So we need to specify the Microsoft Code Analysis is common. To resolve that. Okay, obviously I do not know how to fix NuGet ambiguity errors. CLI. And CLI has workspace MS build, which is common, and which is really common because install reference common 4.7 directly to. There it's okay. I should just read because it says what to do. Fetch over the tool to resolve this issue. Microsoft Code Analysis is common. Yeah, but we are doing that, are we not?
Yeah.
Should we solve the issue? Okay, that's not a different one. Common also to the CLI.
Okay.
And also to CLI tests. Why does this not? Okay. Should we, why we can't upgrade this? Should we downgrade everything to 4.0 to give that a try? Let's give that a try.
Okay.
Yeah, now the central package management would really be handy.
Yeah. Totally.
What I'm just trying now is find and replace the string 472 to 440. Let's see if this is how big this is messing up everything.
Yeah.
Not at all. Okay, cool. Okay, so that builds.
Wow, I was surprised. Okay.
Yeah, me too. My NuGet resolving is bad. Let's run this.
Okay, and what do we see then with the?
So we see some source files.
Okay.
Where do we see them? Oops. So actually there's multiple results. So we get the project, we build the project, and we have an analyzer result from this project.
Okay.
So we have one project, we have results, because it's one project. We have no additional files. We have analyzer references.
Okay.
Oops. So does this, because a source generator is an analyzer, can we get maybe the source generator from here? Or is this really just the analyzer? Why does it close again? Oh, also, there's a lot of compiler arguments. Wow, 360. There is many items. Those are MS build items, I suppose. We have two package references. We have a lot of preprocessor symbols. We have a target framework. That's actually cool. We can get the target framework with the buildalyzer. Okay, this is definitely, so anyway, the buildalyzer needs to go. We need a session on that. And also Dave is a guest here. Buildalyzer, because listing the target framework, that's cool. Our source files. Of which so those also includes the global usings. This is the generated files that we wanted to exclude from our using thing, but it doesn't. It only contains generated documents. It doesn't include source generated documents.
Yeah.
But maybe they are somewhere to find. Preprocessor symbols are perhaps in the analyzers. There is something with source generators.
Oh.
So could we get from that, it also says the DLL, could we get from that maybe there's one generator that we need, or all of the generators and run them? Because there is the request delegate generator. Maybe. But this would only work for this one because that's all analyzers. Well, I guess it could be, but maybe we could get it working with that, yeah. I'm looking at it, what the suggestion was again. Waslin workspace. So, and then use its Waslin workspace instead of our Waslin workspace.
Oh.
At least let this be our last try.
Okay.
But I would need to look at the documentation. We can say Waslin workspaces. Analyzer.get workspace. Okay, we are here. And we say, but actually we need a project. We don't need a, does the analyzer also has the project? Project in solution is so that's an I analyze. How can we get the
what you want to get?
Basically object of this type, of a project type. So we can get the we can get the workspace.
Okay.
And this is an ad hoc workspace. And and then via that workspace open the project. Oh, but that's not an ad hoc workspace. Ad hoc workspace, we can't open projects. But on the top, we can. Can we get the projects? No. From an ad hoc workspace. We can add projects. We can add projects, but we don't get the projects. Okay, I guess we need to familiarize ourselves with the buildalyzer, but this could be a solution. Project analyzer makes it easy to create a Waslin ad hoc workspace. Yep. But so we don't have an MS build workspace, but an ad hoc workspace. So there is some logging we could do. We can adjust MS build properties, which is nice. We have. Ooh, yes. My bad.
What happened?
Workspace has the current solution. Okay, so we get the workspace. Okay, so this is now different. Why does this not fail? Because we now have two workspaces.
Yeah.
New workspace. And workspace.current solution.projects. Cool.
Easy.
I think we only have one in here, so let's do single.
Okay.
New project. And this would be our project. Now is our tool. That's the web application. Yeah, that does look promising. It has 6 documents. It has, let's see where we go from here. If we eventually run into getting these.
But we still don't know whether they have the.
Well, we do get. Excuse me.
Yeah, no, continue. Are those the same that we got like before, or are they
Unfortunately, yes. It contains
exactly the same.
Yes.
Did we use the wrong workspace at some point?
Maybe.
because I don't know, like, I don't know about you, but I kind of stop seeing some things currently because I don't know, my eyes are a bit tired. So let's go through.
We don't run into the exception though anymore.
Okay.
Are we using the wrong workspace somewhere? Okay.
Yeah, this project C# project. Is that
Let's
using
just,
that?
I'll rename this workspace into something totally different. So we
Okay.
will totally discard this existing workspace.
Okay.
We will not be
C#
forced
project.
to get rid of this code. And we get the workspace from the builderlizer.
Yeah. Okay, so use the right one.
And this will be our new project. We ask the solution. We only have a single project, so we get that project. That will be our web project, and now go from there. But did you change the SDK type back to web from the... No, actually not. So our tool is still, or is back to regular SDK. We could also give that a try. But unfortunately, those only contain the generators from the regular.NET SDK, not the ones from the web SDK.
Okay.
But let's give that, okay. One more final try. .web. Does this mean we also need to change like this into... Yeah, let's give that a try. Okay. And now I can't, if I hit Control, if I try to save, I get an error sound. It's cool.
Uh-oh.
Okay, let's save like this. Oh, we.project.
Wow, okay.
Okay. No.
Oh.
Nah, still just the JSON serializer contexts, which are, because they are included in the regular SDK. You can actually, when we have just having here a super plain .NET Core console application, and this one includes, well, this actually has many generators already, like an interop generator for both JavaScript but also DLL imports. And there is the JSON generator, which in this case isn't generating anything, but in our web application, this JSON source generator is creating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 documents. And I think this is exactly those that we see, 1 to 9. So those are those 10 documents. So we unfortunately still don't get the generators from the web SDK, which is, oh, it's so close, but yet so far. This one. This one. Can you like shift? No, like shift, go intercept to appear now.
Yeah.
Okay.
Okay. But we gave it a good try. A couple of good tries.
I definitely need to familiarize myself more with the builderlizer. That does look promising, for at least, if nothing else, for debug, for finding out what is going on, and maybe we can find the missing piece in the logs and in the tracings that tool is exposing there. And we definitely need to integrate this in a future session. So we have 2 future sessions about central package management and the builderlizer, and we still have to do code coverage and fluent assertions and containerize our tests. Oh, there's so much stuff to do. I guess we have a whole whole next season already laid out.
Totally. Totally. We'll never run out of content. I honestly believe that. Okay.
Maybe next year we're still trying to get a hold of the web SDK's analyzer.
No, don't say that.
Okay.
No. No, we'll figure it out. We've just, we've had a long session. We've, hit our brains against a wall for a while. And I'm sure we'll figure it out soon.
So.
Yeah. All right.
Cool.
Well, is this? I think
this is it. Yeah.
There's no, but okay. Let's have a look at the stuff that we did right, just to finish the night.
Yeah. Yes.
Let's for everybody who also joined later, maybe let's have a look at what we did before that kind of actually worked. Just a bit of a round of 2 minutes.
We do have a. It's the wrong one. We do have a running test that is asserting that if our interceptors don't come from a source generated document, but just from any document, then we want to list now these intercepted calls. We have a source generator, we have a non-source generated interceptor where we have one method intercepting one method and one interceptor intercepting two methods, which are in the original code, those up here. And we want to expose these or list these, and then have the test here that we actually do find them. We find the locations of where the interception is going on and where the intercepted, what method is actually invoked. And we would love to see this information now for any project, but maybe it only works for non-web SDK projects.
Okay. Fair enough. Well,
for now, until we figure it out.
Until we figure it out, absolutely. So, until we figure it out or you figure it out, and then you can write us and message us and tell us how you solved it, and if you have any suggestions and want to reach out. Can we Are we going to have an Inception episode?
What is actually? What is happening if we try to intercept that? So if we have an interceptor that is pointing to this, no, hold on, no, you can't, because you need a call site. You can't intercept interceptors because this is not a call site. We can't intercept just a method. We need to intercept the call site. But if we have two interceptors trying to intercept the same call site, so if I would copy this down here to a different interceptor, it would fail. Compilation would fail because we would have two interceptors contending the same call site, and this will be a compile error. So no, interceptors cannot be intercepted. Or not yet in this experimental version of it.
Totally. No, but if you have any more suggestions and want to reach out and let us know your thoughts, you could reach out via LinkedIn. And you could follow us and also keep up to date about our upcoming episodes. And we have, again, a super, super cool episode coming up for you guys. When will next time be?
Ooh, yes. So we will. Where is it? There it is. No, there it is. No, there it is. We have a next session in 4 days already, which will be just before the .NET 8 release. So on Sunday we will have a peek at C# 8, and we will get help by Stuart, and Stuart is actually in the watching today.
Hello! I didn't know that. You didn't even tell me.
Can we? Well, I said Stuart, so okay. So yes, and he will be helping us and showing us all the new C# 12 features, and then will challenge us to implement these in our current solution. and C#12 our code base.
Amazing. I'm honestly really, really looking forward to it. Thanks for joining as well. And for everybody else who's watching, please come back. Like, don't miss this opportunity. I think it's going to be awesome. So on Sunday at what time was it again?
At 1800 UTC.
1800. And so usually, you know, we suggest some content for you guys, but it's only a couple of days, but we still have some content. Like if you want to learn something new, if you're interested, we have a couple of meetup suggestions, or I guess content suggestions.
So tomorrow is by JetBrains is hosting test-driven development with Blazor. I can imagine it will be using, I forgot the name. What's the testing framework for Blazor? Not testing library. I forgot the name.
Uh-oh.
Blazor unit testing. B-unit. I can imagine that will be including B-unit. Oh, let's find out.
Let's find out tomorrow.
This will be tomorrow, actually. And another online session is tips and tricks for building your .NET MAUI apps, which I think is by Mehdi Montakila, who is a developer on the .NET MAUI team.
And also, if you
product manager even.
The hackathon, you can do MAUI projects there, right? So
yeah,
if you're interested in that, get some insight.
And there will be more Blazor as well. How one code base could serve mobile, desktop, and web applications using .NET MAUI and Blazor combination. So combination of both to have a... What's an app that runs everywhere or serves every platform?
What?
I don't know if there's a name for that. Like an app that runs everywhere. Well, I think it's called a browser app.
Okay.
And yeah, posted the links to the sources in the chat.
Amazing. Yes, so these are the meetups that we'll definitely be looking at. I'm definitely going to be looking at that one tomorrow. I'm not sure if I'm busy on Friday, but yeah, up to you guys. Thank you, as always, so much for joining. Especially, I'm really happy today because all of our regulars were here. And it's the first time that I noticed that like all of you are together, assembled to help us with Interceptors. So thank you so much, and also thank you for everyone who's joined for the first time. I had fun. Even though like we ended on a slightly like downward note, but I think I had fun. I was very proud of my live typing and copy pasting skills today. So I'm happy. Are you happy, Stefan?
I'm happy, but it's an angry happy. It's so close. It's so close. Maybe it's just one line, some character missing somewhere saying please do web and all is good. Yeah. Maybe it is.
Absolutely.
Also, Eric says hi, but I'm afraid we are out of power for today.
But we'll be back on Sunday, so definitely
we're back on Sunday.
Yeah.
And will be a lot of syntactic sugar.
We will be a lot of syntactic sugar. So we just said, oh, there will be.
There will be. No, there will be a lot of syntactic sugar.
Okay, good. All right. Then I hope you have a lovely the rest of your evening or day or wherever you're tuning in from. And we'll be back.
We'll be back.